The recent study by scientists from the University of Leeds, the University College London, and Edinburgh universities found that we lost nearly 28 trillion tons of ice between 1994 and 2017. And that's the equivalent of having 100-meter thick of ice across the whole of the UK gone. And some of that ice is already in the oceans, and so that doesn't contribute directly to sea level rise. But the other part of it is from land. And one of the points that the authors brought up is what we call this positive feedback mechanism when we melt ice. So ice is bright and white and it reflects a lot of light. So when we start melting these ice sheets and ice bodies, we start replacing that white and reflective surface with darker surfaces that absorb a lot of heat, and then that leads to even more warming that causes more melting, and therefore it's a self-reinforcing cycle. So when we think about the melting of ice sheets and sea level rise, we think we're putting more water into our ocean basins, and therefore sea levels should rise everywhere, just like we're filling up a bathtub. But the reality of that is more complicated, because sea level rise is not going to be distributed everywhere across the globe in an even manner. And in fact, places that where the ice is melting actually experience a sea level fall. And that's because the ice sheets are no longer weighing down on the land as much. So if you imagine the land as a memory foam pillow, and you're exerting a force down on these memory foam pillow, once you start melting the ice and you're removing the weight of these ice sheets, the memory foam pillow will start to rise and regain its original shape. And that's what happens when we melt ice on land. The land will start to go up, and so locally, sea level falls. And at the same time, the water that melts from these ice sheets and glaciers will flow towards us in the equator. And so being in this region, we're actually set to receive a disproportionately large amount of sea level rise by as much as 30% above the global average. And so it's very important that we think about sea level rise and melting of ice sheets, even though we're very physically removed from where the ice sheets are. A lot of the work that we do here at the Sea Level Group in the Earth Observatory of Singapore is to try and reconstruct how sea levels have changed in the past over hundreds to thousands of years. And one of the reasons why that's so important is that some of the processes that drive sea level change happens on timescales that are longer than what we can observe with modern tide gauge or satellite data. And so if we want to understand how these processes can influence sea level change in the future, then we have to look at past sea level changes. Another reason why it's so important that we look at past changes in sea level is that there's still a lot of uncertainty in the future behaviors of our ice sheet. So Greenland can cause global mean sea levels to rise by potentially 6 to 8 meters, and Antarctica potentially 68 meters if they were to melt completely. But we still don't really know how much of that will melt or how quickly that will melt, because we still don't fully understand how ice sheets interact with the climate. And so if we're interested in how sea levels will change in future under a climate that's different from today's, we have to look back at how different ice sheets have responded to different climatic conditions in the past. Additionally, the water that melts from the poles flows towards us in the equator. And so being able to reconstruct how sea levels have changed in this region will tell us about past ice sheet behaviors. And the way we reconstruct sea levels is to try and understand the relationship of geological proxies to the sea. So for instance, if we're looking at mangroves, which we know are coastal plants that need seawater to survive, if we can find evidence that they could once live at a higher elevation, but today they can only live at a lower elevation, then we know that sea levels must have fallen. And then we can do the same thing with corals that also have a certain established relationship to the tides. And because there's still not a lot of data that has been collected in this region, it's never been a more important time to try and obtain this data and try and understand different processes that contribute to sea level change. So some people may wonder, why is this work so important? Why do we have to understand past sea level changes? Well, the work that we do will help us to understand where the threats of sea level rise are, which areas are going to be more affected by sea level rise, and how they're going to be affected by sea level rise. And hopefully this will help guide low-lying communities and regions better prepare for sea level rise and think about mitigation strategies.